Chapter 6.3 is about the binomial model. The binomial model is something that you are going to say applies if all of these are okay, and you're always going to want to check it to make sure that it is okay to say that it is binomial. So there's a fixed number of trials. The second thing, only two outcomes are possible. It could be yes, no, could be heads, tails, success, fail, etc. The third thing you're going to check is that the probability of success, which they say is P, is the same for each trial. And then the fourth thing, all trials are independent, which means one does not affect the other. So there were some here that you had to look to see if they met or not. And so the first one says 40 randomly selected college students were asked if they selected their major in order to get a good job. Yes, it is binomial because there's a set number, which is 40. There are two outcomes, yes or no. The third one with the same probability of success, yes, that is met because 50% would say probability of saying yes, 50% probability of saying no. The fourth one, they're independent because just because one person says they selected it to get a good job doesn't mean the next person will. If we take a look at this next one where it says 35 randomly selected Americans were asked what country their mothers were born. It's not binomial because the first one is met because there is a set number, there's 35. But the second part of that is not met because there can only be two outcomes. There's more than two countries that the mother could be born in. The third one, where the probability is the same for each trial, is true because however many countries there are, the mother still is only born in one out of all the countries. The fourth one is also met because where one mother is born does not affect where the other person's mother is born. With surveys and independents, the binomial model may be used if the respondents of a survey are selected with replacement, which means you put everybody back into the survey and pull out a name again. If the selection is done without replacement, then the population size, the entire size, has to be at least 10 times larger than how many you are going to be pulling out. For example, if you are going to do a sample of 50, your population has to be at least 500. Binomial notation is just a B parentheses NPX, where N is your sample size, P is your probability, and X is the success, how many successes you have. You can look at that on your PowerPoint. These you can go through on your PowerPoint and just look at to make sure that you know what they're talking about when they say these words. The binomial coefficient is just saying how many possible outcomes are there. The factorial, that explanation point, just means that you multiply all the numbers that are less than or equal to that number. So for instance, if it's 5 factorial, you multiply 5, 4, 3, 2, 1 times each other. The nice thing about this is we can use StatCrunch to find it. And so when we use StatCrunch to find it, you're going to go into Stat, Calculator, Binomial, and then Standard if only one X value, Between if you have two X values. So please make sure you're playing around with that so you know how to find things using this. We'll go through an example and I will put that on a different video. But I wanted to also talk to you about this exact value. If you're asked to find the exact value, what that's saying is if you roll a 6-sided number cube 30 times, then you would expect to get it a 2 30 times 1/6, which is 5 times. For a binomial distribution, mu equals NP is called the mean or the expected value. So when you are asked to find the expected value, please take the number times a probability and you'll get your mu. For your binomial distribution with n trials and probability of success of p, it has a standard deviation, which is sigma equals the square root of np times 1 minus p. When you do this, please be careful that you take the square root of all of this multiplied together.